Here we're going to look at topic 73, example 5, factor a sum of squares. How can you use complex numbers to factor the sum of two squares? Part A, how can you factor the expression x squared plus y squared? All right, there's some methodology behind this. I'm just going to show you what to do, not going to explain it in tons of detail. I'm not really going to explain the why behind it. We'll cover that a little bit more in class because it's a little more complicated, and I want to try and keep this video pretty direct and pretty simple and just give you the how, not so much the why. All right, so when you're factoring expressions, now this is the sum of two squares, the sum because we have a plus sign, right? In the past, if we had something like x squared minus y squared, this became x plus y times x minus y. We were pretty familiar with that. If you had x squared minus, say, 16, you would take the square of both sides, or of both pieces, and you'd have x plus 4x minus 4. All right, so this was the difference of two squares, not what we're looking at right now. So this was a difference. Here we're looking at the sum of two squares. You're taking the square root of both pieces. Okay, so if we have x squared plus y squared, it's still going to be broken up into two binomials. The square of x squared is x, so we would do x and x in each group. The square root of y squared would be y, so we would do y and y. We're still going to do plus, we're still going to do minus. The only thing that changes is the second term where we're adding that y squared. It's going to be yi minus yi. All right, and that's it. That's the only thing that changes. So let's say you had, instead of x squared minus 16, you had x squared plus 16. You would still create two binomials where you had x and x. One would be plus, one would be minus. The square root of 16 is 4. But instead of stopping there, like we did in the difference of two squares, the second term is just going to have an I value. All right, it's the only thing that's really added to this. So I don't want to overcomplicate it. Again, I'll go through the why of this in class for those of you that are interested, but really just know the how, know what happens. So if we look at part B, how can you factor the expression 12x squared plus 3? Well, neither one of those are perfect squares. However, they do have a 3 in common. I would factor that 3 out, and I'd be left with 4x squared plus 1. Those are perfect squares. So I'd have 3. I'll create my two sets of binomials. The square root of 4x squared is 2x. So I have 2x and 2x. Square root of 1 is 1. So I'd have plus 1 minus 1. And then I would just put an I with that second term. You don't really need the 1 anymore. So you could say 3 times 2x plus I times 2x minus I. That would work as a simplified form. So again, don't worry too much about the detail and the why and what's going on behind the scenes, especially in part A. For now, just understand that you do this pretty much the same way as you would difference of two squares, but for the sum of two squares, our second term needs that I value. Okay, so we need to put that I value there. That's it. We're going to stop there. Let's not complicate this.